Hello.
Good morning. Good morning.
How's your break?
Well, actually, that's what I'm going to ask you folks this morning. So it's a good question. Uh, Destabilizing, a lot of change in my life.
Okay.
But
Hopefully it's good change.
uh,
That's what I hope.
yeah, I agree. It's a difficult assessment to make at this point, good, bad, or otherwise. But certainly it's happening. How about yourself?
It was rough.
Yeah.
My sister has a connective tissue disorder, Ehlers-Danlos,
Mm.
and she gets hospitalized a lot. She went up to Wisconsin to train with a service dog,
Oh.
but was hospitalized up there,
Mm.
and unfortunately missed Christmas.
Is this an older sister?
Yeah.
I'm sorry to hear that.
But on the bright side, we did celebrate Christmas on New Year's,
Okay. Was it?
and she's doing a lot better.
Is she home now?
Yeah. Yeah.
Kind of a, was it what I heard a lot about, a Zoom Christmas, Zoom celebration kind of deal?
We waited till she got back to.
Yeah. Yeah. Wonder what that's like for families that had to celebrate or delay their celebrations due to family members being in the hospital or being sick.
Yeah. It's difficult, but on the bright side, when my sister wanted her house to be decorated, the whole neighborhood pitched in.
Wow. Wow. Awesome.
Funny enough, she lives 2 houses down from me.
Oh, okay. So she's like an adult, not like a teenager. She's like an adult, established.
Yeah, like 21. Um, yeah.
Yeah. Yeah. Well, I'm going to be interested to see, maybe even here, if we have time to do a little whip around, albeit across Zoom, just to give people a chance to share their one-word experience of break, what it was like for everybody.
Okay.
Here comes Ethan. I think maybe not. Yeah, here comes some more people. Today's a pretty low-key day. Want to make some connections to last semester's learning and set us up for this semester's learning, and do that all in a remote learning setting, at least for these next few days. So hopefully we'll be successful. We'll find out. Ethan, Annabelle, good morning. Silence. I hope you're there. Any announcements in respect to the big election last night? I know they declared a winner for one of the races. Oh, sorry, I'm checking the New York Times right now. No call for the other race. Narrow. Oh my gosh. 0.3 of a percentage point. Wild.
Close.
I'm probably a bit of a masochist. 8 days are my light day, so I try to get out, walk around Clayton and the like, listening to the phone call, the president phone call with the lawyers and the Georgia Secretary of State that was recorded on Saturday. Wow. Wow. Remarkable. Absolutely remarkable. Worth listening to if you have an hour. For no other reason than as a teenager to begin to understand that it didn't always used to be that way. At least I don't think it was when I was your age. There would be a political figure actively and on record saying something that was demonstrably not true. But like I said, I'm a bit of a masochist. Good morning, everybody. As you pop in, Jack and Vivian, Natalie and Gabby and Isaac, Kellen and Rory and Sophie and Tanner, Cameron and Ryan. I already said hi to Annabelle and Ethan. Here we are once again. Just a second to join us. And then we'll get started. Alrighty. Well, welcome. In a moment, I'm going to ask you to summarize your winter break experience in a word, maybe more than one word, but not a lot of words. Because really, I'm curious, and I'm hoping if you recall, as we wrapped up last semester, one of the tasks that we completed was with the mood meter, where you kind of assessed where you were at that moment, and then you asked yourself where you wanted to be at the end of winter break. You might even recall where you dragged your dot on that particular day. I wanted to check in with you and see, were you able to set that intention weeks ago and actually, maybe not reach that goal, but move closer to that goal with the 12 or 13 days that you had between then and now. The rest of today is going to be really an asynchronous learning experience. I think, although I could be completely misjudging this, I've left some feedback either out loud or in the chat. Me talking to you for an hour seems like a terrible use of our time. So instead, what I've set up are a couple of short ed puzzle videos that ideally are going to connect where we left off at the end of last semester to where we're going to be going at the beginning of this semester. And the topic, it might seem like it doesn't fit, but I think as you watch the videos, you'll see how it does fit, is one of the biggest questions that biologists are striving to answer. And that's, okay, great, so you understand biochemistry? Then use that knowledge to explain where life came from, how life originated on planet Earth. Certainly at some point in history it did, and through natural selection and evolutionary processes, it gave rise to all the different forms of life that exist today. Heck, all the different forms of life that have gone extinct since that origin of life, that date of origin. So really that's the topic for today, is to connect some biochemistry to the processes that would have been necessary for the actual molecules required for life to come into existence. And then once those molecules existed, how might they have come together to give rise to the earliest forms of life, the first cell, if you will. That's going to be an asynchronous experience for the bulk of class. And then with the last 10 minutes, I'd like to come back together as a larger group and kind of highlight what I'm hoping are the takeaways from the videos that you watched during class time today. So that's our plan of attack. Before we get started, though, I wanted to mention just briefly couple of things that I've been asked to share with you. First, picking up supplies if you're a learning at home student. There are these times this week where you can come by school and pick up like books for English, other supplies that you might have for other classes that you're enrolled in. Please take a look at that schedule and swing by if you haven't already. And then starting next week, if you're a learning at home student, or if you find yourself on the quarantine list for any reason in particular, just remember that AM sessions of class, so this is like the A through L part of the alphabet, they will no longer be streamed in the morning. So there will no longer be any Zoom meetings in the morning. They will exclusively be taking place in the afternoon. So just a reminder, so if you have been coming in the morning, say for this class, then just make an adjustment in your schedule to do that in the afternoon instead. All right. Any questions about the logistics before we get started with the actual content today? How school's going to work. Okay. And I have been told this is the plan for at least third quarter. If I was a betting person, I would say this is for the rest of the year. Okay. So just as you think about your plans moving forward. All right. Well then, as I mentioned a moment ago, I'm curious, I'm hoping you're willing to share. If you think back over your experience of winter break these last 2 weeks or so, is there a word or a couple of words that you can use to summarize that best represents your experience? And if so, could you write it or draw it in that box? There's our missing person. Oh, 2 missing people. There we go. Okay, so I'm hoping you're willing to try something a little bit different. Rather than just looking at the responses, my hope is that you're willing to share your word or few words out loud. And I'm hoping that you're seeing on your screen what I'm seeing on my screen. So Trevor, if you're willing, this is not required. Since you're kind of in the upper left-hand corner, you can start us off. What word or words would you use to describe your experience over winter break?
I just simply said change, because a lot changed and a lot was different from previous years.
Okay, thank you. I guess that means I'm next. I already shared this with Trevor. He arrived first. It was a destabilizing experience, a lot of change in my life as well. And I don't know if it's good change, bad change, or neutral change yet, but certainly change was destabilizing. Jeremy, you willing to share?
Yeah, my word is needed.
Thank you. Ashna, you willing? It's okay to pass if you don't want to share.
That's fine. I put like reviving because I thought it was well needed and it kind of lifted me back up.
Thank you. Willa?
I said it was peaceful just because not a lot was going on.
Excellent. Thank you. Sophia, you willing to share?
I just said relaxing.
Relaxing. Annabelle, are you willing to unmute and share?
I just put fun.
Excellent. Ethan, would you unmute and share?
I put helpful.
Helpful. Excellent. Ryan, you're up next if you're willing.
Emotionally exhausting.
Yeah, thank you for sharing that. Miguel?
Calm.
Calm. Thank you. Tanner, you're up next if you're willing to share.
I put lazy.
Lazy, okay. Cameron, are you willing to share?
Oh yeah, I said relaxing.
Relaxing. Excellent. Rory?
I said sleep. I caught up on much needed sleep.
Excellent. Kellen, you willing to share?
I also said relaxed.
Relaxed. Isaac?
I said yawn.
Fair enough. I like that. Jesse, you willing to share?
Yeah, I said too short just because I'm not ready to come back to school.
Yeah, I hear you. Jack, you willing to share?
I said boring but good because it was like boring but also needed, I guess.
All right. Vivian?
I said boring.
Boring, okay. Natalie, are you willing to share?
I said needed.
Needed. Excellent. Gabby?
I said painfully brief because going into it, I kind of overscheduled myself and I had like school related activities that I really thought that I was going to do over break. And then I felt kind of terrible for not doing any of them and just sitting around. But I guess that's kind of what break is for. Just didn't get anything done.
I'm reminded of a phrase I've come across in my own mindfulness practice of just who we are, human beings, and yet we're often choosing, maybe not choosing, but probably ultimately choosing to be human doings and not human beings, and what's wrong with just being sometimes. Jesse, you've already shared. Pablo, I guess you're the last one. Are you willing to share?
I said relaxing.
Excellent. Well, thank you for sharing. I like to hear your voices. I like to hear, I'm hoping you were able to hear everyone's voices as well. And yeah, I'm hoping winter break did what it could for you. And yet here we are again. So again, the bulk of today is an asynchronous experience. I'm gonna go ahead and put you into student mode. And really it's set up so that you can go through these slides one at a time. Some of the slides do have text on them. I would encourage you to read them, but it's brief. You will be taken to slides that hopefully have the Edpuzzle video embedded right into them. If not, there should be a link at the bottom of the page that will bring you to the video. And yeah, you just want to watch the video like you normally would for homework. Some questions might pop up. You want to do your best to answer those questions, and then just kind of move on through the rest of the slides. My hope is you'll have enough time to get through both of the videos. And you'll also see some AP practice multiple choice questions embedded along the way that you can use to assess your understanding of what you see or what you read. My hope is though that we can come back together at right around 9:45 and we'll do like a 10-minute debrief, most important takeaway conversation of what I'm hoping you're seeing as you watch and read. And of course, I'll be here if you have any questions. You can say something out loud, you can post it in the chat, whatever works best for you. All right. What questions do you have before we get started with this asynchronous learning activity today? So again, we'll come back together at 9:45, but hopefully that will give you enough time to get through these two videos and answer the questions along the way. Let me know if you have questions. Just one quick thing. I thought I had set this up so that the reflect and write slides were skipped, but I'm noticing that you can still see them in student mode. For the sake of time, you can skip the reflect and write slides. Just focus your efforts on the practice multiple choice questions. Alrighty, if you could find a good spot to pause so that we can come back together. Right. Well, before I kind of share with you my key takeaways, just a quick reminder, if that's even the right word. You can always go back if you haven't had a chance to finish both videos and trying to monitor your progress in real time. It looks like most people had a chance to watch the first one. Most people have got through the second one as well, but you can always go back and watch it again. They're Edpuzzle videos, or finish watching if you haven't had a chance. And of course, the practice questions are also in the Unit 7 notes. So if you haven't had a chance to answer all of the practice multiple choice questions, the questions are there. They may not be in Pear Deck form, of course, but the questions are there, and the answers are down below if you want to look at the answers. So just a reminder, and that's been true all year if you haven't been aware of that. Before I also share my takeaways, is there anything that you're wondering about or curious about? There's a lot here.
Have scientists ever run an experiment where they just do the soup thing for a long time and see if anything else develops? And what were the results of that?
Yeah, so I mean, when you look at the actual Miller-Urey experiment, you're talking about an experiment that was first conducted in the mid-20th century, right, 1953. So at the end of the video, there are kind of like these still images of different scientists who are still working on this question. And absolutely, positively, dozens, if not hundreds of permutations of that experiment have been conducted in the last 70 years. So you change the composition of gases in the primordial atmosphere. You change the source of energy. Hopefully you notice that, you know, the lightning strikes that they're trying to simulate with those electric discharges, right? That's the energy required for anabolic synthesis of these molecules. That's a connection from last semester, right? We can't put molecules together. We can't put atoms together, right? Unless we have a source of energy. So absolutely, the different permutations of this experiment have been conducted, really with the goal of seeing, for example, okay, great. Miller and Urey demonstrated that you could get a few amino acids out at the end of their experiment, but could you get all 20 amino acids out? Maybe not all at once, but in different combinations over the course of time. And they've done that. Scientists have done that over the course of time. They've also got out the nucleotides, the building blocks of nucleic acids like RNA and DNA. They've got all the common carbohydrates, glucose, fructose, molecules like that. So short story long, they have been able to demonstrate that it is entirely possible through natural means to generate all of the molecules that are required for life to exist. What else before I share my take-homes with you? Well, then briefly, I'm going to kind of scroll to the slide and then take you out of student mode here. You saw a version of this, I guess, this progression that would have been required for life to emerge on Earth in the Miller-Urey experiment video. So we can always come back to this, but I wanted just to focus briefly on the fact that really we're focusing on about the halfway point on this chart. So we're not even getting all the way to the end. We're just trying to give rise to organisms that are really, really simple. So this term microsphere or protocell, right? We're talking about really early life forms, really just things. We can't really even call them cells necessarily, but entities that would have been surrounded by some external boundary, okay? And later, next time on Thursday, when we get back together, Friday, when we get back together, we'll be looking at what that boundary actually was most likely composed of and what it's composed of in all of our cells today. But just as a brief reminder, we're not getting to the point where oxygen is available in the atmosphere. So we're dealing with an environment that would not be conducive to life like ours. And we're not even dealing with multicellular or eukaryotic forms of life. So no organelles are in these cells that would have emerged on the early Earth, okay? So we're very, very simple, very, very simple in terms of what this life would have looked like if we could go back in time and actually look at it. All right, so what is important to take away from this? Well, first, if you've had a chance to watch the second video, we need a form of genetic material, of transmissible hereditary material that all indications point to would have been RNA, a close cousin of DNA. So even the genetic material that we have in our cells would not have been the genetic material found in this early life form. So once it formed, right, it had to have a way to copy itself. And here's what's crazy. These molecules of RNA, they're not polypeptides. They're not composed of amino acids like we learned about in the last semester. And yet, these linear chains of molecules can fold back on themselves into three-dimensional shapes that have enzymatic activity. So the hereditary material, the RNA that would have served as the hereditary material in this first cell, also would have had the ability, or would have had to have the ability, to fold into a three-dimensional shape and copy itself. That's number one. Super important. We have to have a way to copy this genetic material. If we have that mechanism in place, we also have to encapsulate that genetic material and the copying mechanism within some sort of boundary, within some sort of membrane. The membrane most likely was composed of a fatty molecule. So we'll be learning about this in the next time we get together, but the molecules that would have been necessary to form this boundary, this membrane around that self-replicating genetic material existed on the early Earth. And here's what's nuts. Those structures formed spontaneously. They formed all on their own without any outside intervention. So genetic material that's capable of self-replication is now enclosed within a boundary, within a membrane. And then last but not least, if you've got that, if you've got a structure, right, that encloses a self-replicating form of genetic material, the last piece is you've got to have a way for that cell, early cell, primitive cell, to make more of itself, okay? And that's what I want to leave you with in a short video clip here at the end of our time together this morning, okay? Because if you've got all of these things, what you have is an early form of life. So again, a self-replicating form of genetic material enclosed within a membrane could have been representative of the earliest life form if that life form was also able to make copies of itself, to reproduce. So believe it or not, scientists have actually done these sorts of experiments in their own laboratories. So what you're looking at the screen right now is an example of what very well might have served as that first life form. It is a membrane enclosed structure that's glowing. So that white that you see is glow. It's a fluorescent glow. And those fluorescent molecules inside of that structure could be RNA, as an example, or the machinery that would have been required to replicate that RNA. But what I'm hoping you're seeing is that it's enclosed within it's a two-dimensional image, of course, but it would have been a spherical structure if you could see it. And as I press play, everything that you're going to see is being recorded under a microscope. So these are really, really tiny structures. Okay. And what you're going to begin to see in this short video clip is this cylindrical or spherical structure begin to grow. And what's happening is that this structure is being provided with the very molecules in its environment that are necessary for its membrane to grow, to expand. So if I press pause, you can kind of see like this tail structure that's forming. That's the membrane of this early cell growing outward. Its surface, if you will, is increasing as more and more of the molecules that are used to build this membrane are being incorporated into it. Come on, buddy, play. There it goes. Oh, nope, it's not playing, is it? I never should have paused it. See if I can get it to go again before we run out of time. Here, I'll just do it again. It's really short. It'll just give me 30. So sorry, I had to reset it. But again, here's the structure. It's growing. And what you're going to see at the very end is the structure that's expanding, that's growing outward as more and more membrane is added to it. You're going to see it break up into separate little structures. Let's see if I can capture it at the exact moment before you go. So there it is again, this long extension of membrane that's still encapsulating, it's still surrounding an internal environment. And then 3, 2, 1. Bingo. There it is. They were able to take that single structure and get it to reproduce into separate structures. So short story long, scientists have been able to not only simulate the conditions that would have been present on an early Earth to create these molecules, they've then been able to take those molecules and build the very structures that might have been representative of the earliest life forms and get them to reproduce. It's not pie in the sky. It's not some ethereal question that can't be answered. We're answering the questions in laboratories all around Earth right now. Okay. So that's what I wanted to leave you with. Thank you for your time, your effort, and your attention this morning, and I will see you in a couple of days.
Thank you.
Thank you.
Thank
Thank
you.
you.
Thank you.
Thank
bye.
you.
Hey.
Good morning. I have to watch all of you like vigilantly to see when your audio connects so that I know when to say good morning. And then I miss you if I don't pay attention. Good morning, Sarah. I can see you're connected. I know that you can hear me. Well, I hope you can hear me because I don't know that you can hear me. Well, that is the question I'm going to ask all of you folks. How was break? See if you can summarize it in a word or two here at the beginning of our time together. But I'll answer the question now. A lot of change. A lot of change. I don't know if it's good, bad, or neutral change yet, but a lot of change in my life. Be the best way that. Get this to do it. Oh, hello. Good morning, everybody. It's nice to see your faces. Or your favorite NFC soon-to-be champions, right, Tom? First round bye. Home field advantage. Although, what does that mean in 2021, right? In terms of playoff team, you enter a stadium, but there's no fans there. Of course, that logo could be code for something else I'm totally unaware of. So. Fast and Furious. Good morning, everybody, as I let everybody in. Thanks for logging into the Pear Deck. Got just about everybody. That's great. Right. Well, here we are once again, right? There's somebody. Couple quick things that I've been asked to share with you that are not related to our class specifically. Maybe you've already heard them. I apologize if you have. But if you're going to continue to learn from home, and there are some supplies that you need to pick up or books that you need to pick up, there's some time on the calendar that you can stop by school and pick up those items. So I've just been asked to remind you about that. That probably also applies, well, maybe it doesn't apply if you're going to come back into the building next week. Maybe you can still pick up those things, but I've been asked to remind you about that. And then just also a reminder starting next week, if you're going to continue to learn from home by choice, or if you have to learn by home because you've been quarantined for a reason, or just a reminder that there will no longer be any AM Zoom sessions. So all learn at home sessions will take place in the afternoon exclusively. So if you've been one of those A through L people and you've been coming into your classes in the morning, now you can just go to your classes in the afternoon. Okay. Just been asked to remind you about those two things as we get started this semester. Do you have any logistical questions about school before we hop into the biology for today? Okay. Well, welcome. Like I said, here we are again. I thought we could start today with a really simple check-in. It's a one-word check-in, and the prompt, I'll show you the prompt here, is going to be, can you summarize your break experience in a word or maybe a couple of words? You might recall that before break, we did a mood meter where you assessed where you were in that moment, but then also tried to kind of project outward and think about where you wanted to be emotionally after break. So as you think about that and setting the intention that you set, almost 3 weeks ago now, how did break work for you? What was your experience? Can you summarize it in a word or a couple of words? I'll give you a chance to do that right now. Okay. So I want to try something a little bit different just in terms of sharing. And this is really, you don't have to do this, but if you're willing to share your word or words out loud, just by briefly unmuting yourself and sharing, I would appreciate it. And I will be part of that as well, if you'll allow me to be. And of course, you don't have to. If you want to pass, that's okay. But I thought we'd just kind of go around the Zoom window and just share your word or words briefly with each other. If for no other reason than to hear each other's voices, because how often do we get a chance to do that? So just kind of starting from the, I guess, the upper right-hand corner. Caitlin, are you willing to unmute and share your word or words?
Rejuvenating.
Rejuvenating. Thank you. Maya, are you willing to share?
Short but good.
Short but good. Jonah, you're up next.
Uneventful.
Uneventful. My break was filled with change. Sarah, are you willing to share? Okay. Moving down, we'll just kind of move down right below Sarah. Tyan, you willing to share?
It was really relaxing.
Relaxing? Thank you. Abby, you're up next.
I also said uneventful, so I drew a picture of a flower
Oh, I guess I could pull up the pictures, couldn't I?
and the sun and some grass. So
Well, now we have to find your artistic rendering, don't we? See if we can find it real quick. That pig always makes an appearance. Of course, I'm not gonna, there it is. That's gotta be yours, right?
my picture. Yeah, that's mine.
All right, Max, you willing to share?
I said depressing.
Okay, thank you. Alex?
I said that it was needed.
Needed, sorry, there's two Alexes. So thank you. Thank you, Alex H, now Alex P.
Oh, I said restful. Like I think, yeah.
All right, thank you. We'll kind of come down. Ben?
I said lazy.
Lazy, all right. Sasha, you willing to share?
I also said relaxing.
Okay. Ingrid?
I said chill.
Okay. Tom, you willing to share?
I said good.
All right. Lauren, you're up next.
I said something because it was quite an adventurous break.
Yeah. All right. Thank you. Elliot, you willing to share?
Tense.
All right. Don?
Sure.
Short. Sonia, you willing to unmute and share?
I said peaceful.
Kylie?
I said like relaxing.
Ozzy, you willing to share?
I said relaxing and great.
Fantastic. Thank you for sharing. We'll move down to the last row. Joshua?
I said food.
Food. Fair enough. And Joseph?
Cold.
All right. Jesse?
I said homework.
Okay. And Anna?
I said untraditional.
Wow, that's a great way to describe it. Thank you for sharing. And Paige, you have the last word.
I said uneventful.
Well, thank you for sharing, everybody. It's nice to hear your voices again. And a little bit different, right? Sometimes we just look at what people have written or drawn. But sometimes it's nice to just hear out loud what other people have to say about break. Regardless, I do hope that whatever intention you may have set for yourself a few weeks ago is something that you were able to maybe not achieve definitively, but move closer to with this time that you had to yourself, with your friends, with your family, however you best chose, with your pets, however you best chose to spend it. Okay, so thank you for sharing. Our plan for the day is really an asynchronous learning experience. I cannot imagine what it would be like to sit wherever you're sitting and have an adult talk to you for an hour. So I am not going to do that. Instead, what I have created for you are a couple of Edpuzzle videos that ideally will connect where we left off last semester to where we're going this semester. And the bridge between those two worlds actually addresses a question you may have thought about at some point in your life, but certainly a question that biologists think about quite often. And that is, okay, great. If biology is a study of life, then where did the first living thing come from? And how did it come into existence? And believe it or not, an understanding of biochemistry, where we left off last semester, is the starting point to answer that question. And while we have not definitively answered that question as biologists, we're getting awfully close to what would have had to have happened in order for that living thing to come into existence at some point in Earth's history. So that is really the bulk of today's lesson. 2 videos that you can watch at your own pace. And then with about 10 minutes to go in class, we'll come back together, answer any questions that you might have, but also kind of put an exclamation point on what I think are the most important takeaways from the videos that you watched during class time. So what I'm going to do is put you into student mode. And that'll give you the ability to move through the slides at your own pace. Some of the slides do have text on them, so I would encourage you to read those slides. Some of the slides have practice multiple choice questions from released AP exams, so I would encourage you to answer those questions to the best of your ability, and then watch the videos as you come to them. I'll still be here answering any questions that you might have along the way. You can say something out loud, you can post in the chat, whatever works best for you. But again, we'll come back together with about 10 minutes to go. And again, I'll highlight what I think are the most important takeaways from what you saw today. So before we begin, what questions do you have for me or for the good of the group? Okay. Well, work at your own pace. If questions pop up, please don't hesitate to ask. We'll come back together with 10 minutes to go, which will be about 10:45. So you've got 30 minutes to work.
Are the videos on Google Classroom?
They are not on Classroom. So if you're having trouble accessing them, probably the fastest way would just be to log into Edpuzzle, and the videos will be on your Edpuzzle page as well.
Okay, thank you.
We've got about 20 minutes left. Just if you didn't see it in the chat really quickly, you can skip the reflect and write slides. I actually tried to skip them in the slide deck in the first place, but I see that they're showing up anyway. Save time, focus on the multiple choice questions, but skip the reflect and write questions for now. We'll come back together in about 5 minutes. Hopefully you'll have a chance to watch both videos before then. All right. Try to find a spot to pause, and we'll come back together just for that debrief here for the last 10 minutes. So before I offer my key takeaways from what I'm hoping you saw in the videos, do you have any questions or things you're curious about before I do that?
Yeah, I have a question. I think in the video it said, in the video on early first life, they said that a living thing has to either be made of cells or like create a closed system with its environment. And does that mean that being made of cells is not a necessity of a living thing?
Yeah, it's a
Or
great
is it-
question. It's a great question because what you often encounter, especially given what's happening in the world right now, is are structures like viruses alive? Because a virus is not cellular. And
Right.
that coronavirus in particular has a membrane that serves as an outer boundary for an inner structure that contains both protein and nucleic acid. So you end up walking this tightrope between living and not living. A virus is not alive because it doesn't meet all of the requirements that were listed in that chart that I put up in the video. It's not cellular, but perhaps even more importantly, it can't reproduce on its own. It needs a host in order to reproduce. So classically, what we would say is that in order to be alive, you've got to meet all those requirements. And one of them is you got to be composed of cells. And even if you come close to being composed of cells, like in the case of a virus, but you're not quite all the way there, you are not alive. You kind of ride this, I mean, call it what you will. You're on the tightrope, you're sitting on the wall. I don't care what metaphor you use, but technically you're not alive.
Is there anything else that straddles that boundary in that way?
Yeah, there are some complex molecules that are not surrounded by a membrane, but have the ability to like self-replicate. So in that second video, something I wanted to highlight just here briefly at the end is that there are molecules of RNA, single-stranded nucleic acid, so a close cousin of DNA that can fold into three-dimensional shapes and are capable of self-replicating, and thus can do a lot of the things that are necessary in order to be alive, but aren't cellular. So are they really alive? No, they're not. And yet they possess some of those characteristics. Like they can reproduce on their own, but they're not all the way there. There aren't a lot of things in the world that are not made of cells and are not considered to be alive, though. It's a fair question. Anything else that I can address here before I share my takeaways with you? Okay. Well, then briefly here at the end, there's a chart similar to the one that's on the screen now. Let me actually take you out of student mode here so that you can see it. See what I'm seeing. There we go. It looks like this. It's kind of like the timeline that would have been necessary in order for life to emerge on Earth. And I just wanted to say that we're only about halfway through that timeline after watching these two videos, right? We've got structures, right? Sometimes they're referred to as microspheres or protocells, coacervates. They have different names. They're not technically cells like we think of cells today, modern cells today, but they are structures that contain genetic material that's capable of reproducing on its own or replicating on its own. But we're nowhere near some of the terms you might remember from middle school, like eukaryotic or multicellular forms of life yet. We're still talking about the simplest of simple forms of life to have existed on Earth 3.5 or so billion years ago. So I just wanted to highlight that briefly before we go any further.
I have a question.
Yeah.
It might be kind of stupid, but what exactly is how you define if something is or isn't a cell?
Well, actually, it's a great question because it's a nice segue into what I wanted to share with you as the takeaways from the videos. So actually, let me see if I can do that here real quickly and see if I can answer that question along the way. So a cell is a structure that has genetic material on the inside and an outer boundary on the outside. So when we talk about the simplest forms of life to have emerged on Earth, what I'm hoping you saw in the first video is that the molecules required for both the genetic material and for that membrane to form around it could have formed through natural processes, through chemical reactions taking place on an early Earth. So if you've got genetic material enclosed within a membrane, within a barrier, you have a cell-like structure. But what we need is for that cell-like structure with its genetic material on the inside, and that genetic material is most likely to be RNA at the beginning of life on Earth, is that RNA has to have a way to replicate itself. But what's cool is that these RNA molecules, much like polypeptides, can fold into unique three-dimensional shapes that give them enzymatic activity. So much so that some of these RNA molecules could fold into three-dimensional shapes with enzymatic activity that allow them to replicate themselves. That's nuts to think about that it's actually possible, but biologists have demonstrated in their labs, modern labs, that it's entirely possible. So we've got genetic material, probably RNA, it's capable of replicating itself, and it's enclosed within a membrane. That's a cell. But we also need that cell to be able to make more of itself. We need to have a way for it to reproduce, okay? So that's kind of take home 1 and take home 2 together. We've got to have genetic material, that probably RNA in the history of life on Earth, that was capable of self-replicating, and we need it all enclosed within a membrane. And that membrane was probably composed of fats or fatty acid molecules. So there's another connection to what we talked about last semester. But the final piece is, if you've got that cell, you gotta have a way for that cell to reproduce. And what I wanna share with you in these last couple minutes of class is that biologists have actually come up with a way in their own laboratories to demonstrate how that would have been possible. Okay. So Maya, do you feel like I'm getting closer to answering your question?
Yes, this is helping.
So let me show you in this really brief video clip how that reproduction step, right, making more of these earliest forms of life, these early cells, could have happened on an early Earth. So what I'm hoping you're seeing on the screen right now is like it's two-dimensional, but it is a spherical object, okay? And it looks like it's kind of glowing. That's because it contains within itself molecules that are glowing, right? They're fluorescent molecules. And all of what you're about to see is being recorded under a microscope. So these are really tiny structures as well. But inside of this really tiny structure, the molecules that are glowing, that are fluorescent, those could be the RNA molecules, the molecules that are capable of self-replication. And because you're noticing, I'm hoping you're noticing that the structure is spherical, it has an outer boundary. It has a membrane, okay? So as I press play, what you're gonna begin to see is that the spherical structure begins to change. It changes shape. And it's changing shape because what the scientists are doing is providing in the environment in which this cell is found the molecules that are necessary for it to build more of this membrane, of this outer boundary. And what you're going to begin to see is that this membrane is expanding. Kind of at this point looks like a string almost. But that's still the same structure that we began with. It's just been elongated. And eventually, as the video reaches its conclusion, what you're going to see is that long, elongated structure, it's going to begin to break apart. Into separate structures. The structure that we started with, that we fed molecules to, that allowed it to expand its membrane, to grow its membrane, to grow its outer boundary, eventually split into separate structures. Folks, the damn thing reproduced. So I'm showing you this because as you've watched these videos, you've seen, right, how life could have come into existence, right? The molecules were present. The molecules could self-assemble into the very structures required, to go back to Maya's question, for a cell to exist. And biologists have been able to simulate the very conditions there where if you've got that cell, you can make more of them. So the question of where did life come from and how did it emerge, biologists aren't just trying to answer it. They're not speculating as to how or what the answer might be. They're demonstrating what the answer could have been, with the full understanding that no one's ever going to come up with the answer because we can't travel back in time and know for sure how it happened, but we can demonstrate that it's possible. Okay. So I'm hoping today's lesson gave you some insight into how it was possible, right? So I'm noticing on the minute pass, so I'm going to pause there. Thank you for being here. Thank you for your attention, and I will see you in a couple of days.
Thank you.
Thank you.
Thank you. Be well, everybody.